Okay, we'll start the AMSAT engineering update presented by Vice President Jerry Buxton and the AMSAT engineering team.
Howdy, everybody. I am, as Joe pointed out, Jerry Buxton, N0JY, Vice President of Engineering, and there are several members of the engineering team present, so that's the ones that Joe was referring to, not everybody. Sorry about that. We have seen over the past 2 days a lot of history about our 50 years of amateur radio in space. And truly a lot of great stuff going on with several satellite projects and the focus mostly on engineering satellites. Everything from Oscar 5 to Oscar 95 so far. But we do have within AMSAT much more than just engineering behind all of this. We have all of the various groups that operate the satellites, user services, provide our members with value, the human spaceflight component that Frank does with others, and educational and development, which is a rather new one that Joe will probably touch on when he does his presentation, and of course the corporation offices. So what we have now in a segue from the past is a new group of engineers, essentially, a new generation, and a new style of Cubesat, referred to as the Cubesat Creators. And I have the names of several that are here up on the board, and I'd like to ask them to stand up and face the crowd to be recognized. I will also ask them to each come up and talk. They will each have a chance to give you a little bit of background about themselves as we go along with this show and describe what they're working on. I'll start out with me. And I was licensed in 1972. I've been on satellites since 74, 75, and always been with AMSAT and all the great work that they've done. So to keep the story short, in 2011, I had the wild idea that I should see if I could do anything to contribute to the work that's actually going on. Contacted Tony Montero. He gave me a nice job interview and talked to me about what I knew and what I could do. I don't have the electrical or engineering background or anything like that to go on, but he did seem to find that I would be a good fit for systems engineer, which was a needed position at the time. So, he asked me how long I could put in. I said 4 to 5 hours a week, so he wrote down 45 hours a week.
Remember, it's only a hobby.
That's right. An addicting hobby, right? So I was systems engineer in 2011. Around October, my first symposium was the one in San Jose that year. And in 2014, then, Tony unfortunately passed away, and a few people put my name forth as a possible replacement. Barry talked to me about that, and after clearing it with my XYL, I with no other candidates apparently, it was my choice. I mean, well, I'm not going to let the Fox program die, so I said, all right, I'll step up and do that, and I've been doing that since. Almost finished with the Fox program, and now we're off into golf. So that's how I got here. We, as I said, we're doing all Cubesat projects, and one thing that comes with that, and their small size, and our geographical diversity, is we have a lot less pictures, at least group pictures, to share. Selfies are kind of tough when you're trying to show yourself soldering something, you know. The Fox 1 program was the first Cubesat program, which Tony initiated. We've got 5 Fox 1U Cubesats that have been built, with 4 of them launched, and the remaining one, Fox 1E RadFXat 2, is waiting its turn. I'll go over a little bit about each one just real quick for an update. A085 Fox 1A, the first one launched And it carried a couple of experiments. Vanderbilt University has been a partner on many, if not all, of our Fox CubeSats with their radiation effects experiments. And Tony had talked to Penn State Erie about doing a capstone project, some students there for their senior year, to create a MEMS gyro experiment. They did complete the design of it. They did not complete construction. And we chose to integrate it on an IHU that's in each Fox satellite because of the space we have there and then not taking up one of the experiment slots. So it does fly on all of our Fox 1 satellites. As you probably know, the battery is shot, but it does still work in sunlight, and Drew and Mark are doing a great job of managing it as well as the members and keeping it going as long as they can. So it's been 4 years nearly that's been in orbit, and I think that's not bad at all for a first CubeSat. AO91, this is actually RadFXSat, Vanderbilt University's experiment. They wrote the CSLI for it, in agreement that we keep up again on the Fox 1 footprint. So it's got the same stuff as Fox 1A, if you will, and it is in nominal continuous operation. It has all 4 experiment slots filled with Vanderbilt experiments, and they are very pleased with how this works. AO92 is Fox 1D. This was one of the purchase launches from spaceflight. It was launched in 2018. It's, again, another cookie cutter, so to speak, of Fox 1A. And the use of cookie cutter is easy to say, but duplicating a satellite or cranking them out, at least in what we've experienced from the same pattern, is not as easy as it sounds, because each one of these introduced hurdles, challenges that were totally different than the previous one, and every one of them kept everyone guessing, if you will, and working hard to make sure that they made it to the launch. In this one, we flew the L-band downshifter. That's one of our own experiments because, along with the Virginia Tech camera, the 4th experiment board has a little slot cut in for their lens, and there were no takers on that. So John Klingelhaven came up with the idea for a down converter, essentially, to down convert an L-band uplink signal to the input frequency at 435.x of the receiver. It was deemed an experiment because it was a crazy idea late in the development, but it works quite well. So we're very proud of that. And this particular one, I won't go into the history of the spaceflight launch contract, but the original was going to be launched together, had to be split up, and this one was flown from India on an Israel launch. It too is in continuous operation. The AO95 Fox 1C, and in respect for the gentleman who we had named the satellite after, I kind of dropped calling it by that while I talked about this. As you know, this one was the second one that was going to fly on space flight, the SSOA mission. So it was the latest one to launch, December of last year. And it carries the Vanderbilt experiment as well as the Virginia Tech camera. The Vanderbilt is actually the flight spare from Fox 1A. The Virginia Tech is the second, well, the first of the 2 cameras they gave us. And it was launched on Falcon 9 in December of last year. So we came to find shortly thereafter that it's stone deaf, or as Drew put the receiver is dead. The reason for the failure is unknown, of course, because it's difficult to look inside and try to figure out exactly what it is. Although Bob Davis was the first in line years ago to say, "I'll go look if we need to." Telemetry is nominal. Our telemetry indicates that it's nominal, and the standard safe mode beacon switches into after launch is working just fine. So the only indication we have to go from as far as telemetry is that the RSSI, received signal, is just flat at the bottom of its range. We have tried hitting it with high-powered signals, EME class and such, to see if we can get that to budge or tickle, and then Drew also has observed that the radar noise that we hear typically on the Fox 1 uplinks, or C in the RSSI, that is not present either. Some of the possible causes antenna not deployed would be one, but it was designed and tested that even with the antenna stowed, a good signal would be able to get through and command it. A solder failure, we have experienced those in previous Foxes, none at launch, but during the development or engineering, even flight model phases, they have come out. And the history of that I have spoken of in journal articles and such. I'm not going to give detail here. It's possible then that something shook loose, if you will. The downshifter itself being a problem, since it's in line with the receiver, is a possibility, but RF team rules that out in the sense that it is really quite passive and nominally not even in line. So with no power to it, it cannot get in line. And it's not responding on L-band either, so it doesn't appear that the antenna or signals running through the downshifter in L-band. Launch environment is something that might be a possibility with the SSOA. The deployer saw it is quite a contraption, and there were several other that we know of who have publicly stated several other satellites that suffered some type of malfunction that were on that launch as well, including Cubesat, which was right next to us in the pod. It's my speculation that the levels that we tested to, that they provided us, being that this was the first go-around for that, may have been a little bit short of what actually happened. And finally, we've got RAPXSat 2, which is another Vanderbilt University CSLI, aka Fox 1E. Fox 1E was essentially built from spare parts from the Fox 1 program. And along the way, when we were thinking about whether to do it or what to do, the idea of having a linear transponder was proposed, and so everybody was happy with that and dug in, and we produced the linear transponder. It's again, all Vanderbilt University experiments, and like I noted on some of the other presentations previously, it is sitting in my garage, although in my Fox lab actually adjacent, waiting for delivery. And the launch right now on the Launcher 1 Virgin Orbit is no earlier than the first quarter next year. So now we go to the Golf program. Golf is the current and successor to the Fox program. The Fox was, in my understanding, although it originated, a couple years before I came along, first Cubesat, the wise choice because, as you know from the history, we were able to find launches on all sorts of rockets in whatever shape was necessary. Well, now the industry shape is Cubesat. So we've gone with that, and the 1U had a background of being generally thought of to being more capable than it was, but put through as it was when the 051 started with it. We've learned enough about that, and we've discussed and taken ideas as we went along to go ahead with the 3U, that's a follow-on, and as has been my goal to push things to microwave and higher orbits. HEO is one of the easiest ones to achieve event sense. It's what we're looking for. So the acronym for greater orbit, larger footprint, because that's all I can come up with from the phonetic belt. So I'm looking at a series of 3D Cubesats that allow us to learn and develop the skills within engineering that are necessary, as well as attracting the engineers necessary to be able to achieve what we need to have a good high-altitude satellite. And with microwave and any other experiments, power requirements, the need to steer solar panels and such, attitude control is a major piece of that. We're looking also at trying to get cheap radiation tolerance, which is something that has been traditional. And the ASCENT group came up with an idea toward what we call RT-IHU, radiation tolerant IHU. We'll hear a little bit more about that shortly. And eventually propulsion. So step by step to learn and do these things rather than all in one, because we honestly don't have the total knowledge to do that, although it can be purchased, a black box and a manual, 5 languages, versus the experience and documentation of how to do it for the future is much more palatable. And then the microwave portion, well, of course, smaller you get, the more attractive microwave antennas are, hiding lower footprints. And it's also a bandwidth consideration, because VU, VHF, UHF is so crowded. It's you got satellites QRMing each other. The move to microwave in my design of the Fox 1 program is not a switch, but an attraction. And as was mentioned in the previous presentation, there are people that are interested in experimenting with the experience. So, you can try it out. There's surplus parts. There are people that will help, groups working together and put together stuff to make that move there. Eventually, hopefully leaving VU behind, except for, backup communications on these stuff. So, the pointing is also a big thing too, because the command stations need to know how to do it. If they want to change an attitude, and you don't want to have to get out the slide rule and go for it. So the common elements to the Gulf satellites. Well, both of them first, we submitted a CSLI proposal. They were both selected. Selected does not guarantee a launch, but NASA has been working hard to find a launch for us. It has been an interesting challenge because we want to go higher, and everybody else wants to or is being forced to go lower. So, while the Foxes were a pretty easy selection in that case, the Fox 1, I should say, the Golf has not been quite that. The common elements of Golf Team, Golf 1, 3U deployable solar panels, which are our own protection, if you will, the 3-axis attitude control, which, lacking the knowledge ourselves, we are working with vendors on, because we can learn about how that works and be able to have a better knowledge base of the RTIHU. And they're both going to have VHF, UHF, either in the form in Golf T of a Fox 1E transponder legacy, and that is also the, if all else fails, since it is more, it's open flight tested, it may still be. If everything goes to heck with the attitude control and you can't point the antennas and don't have enough power for the SDR, then, well, we've got the U transponder. It's also flying things, flying an antenna, and the SDR looking at the capability of LS and C-band uplinks. That's been working toward Golf 1, because Golf 1 then will be able to provide a more fully robust SDR capability. We're looking at about a 600 kilometer orbit on that. The idea is rapid deployment. We want to get it up there so that we can find out how that APCS and how the solar panels, deployable solar panels work, how the RTIHU compares to the legacy IHU, which also flies with the 1E transponder, and the Vanderbilt radiation experiment, which is a similar chain that we've flown on all the Foxes, is kind of a baseline to be able to look at what they're seeing compared to what we've seen in the past, and how the legacy IHU performs compared to the RTIHU. We're looking at flying a deorbit device. This was originally planned in the sense that testing such a thing might be able to garner us some options to go a little higher than flat out 600 kilometers. If you want to know more about that, I can talk to you, in detail about how that orbital debris stuff works. But I have so far decided to keep it because it is also a backup in the sense that it would deploy a gravity gradient boom. And if the ADCS were to fail, that would more or less keep the microwave antennas pointed toward Earth, although it will shorten it considerably. And we're going to demonstrate high-speed telemetry on the X-band. our previous partners, well, prospective partners that I've met through most of Cubesat Developers Workshop, but also word of mouth. They're looking for higher speeds on all our stuff. Vanderbilt's a comfortable fit for us because even the 200 bit per second data under voice that's on the Fox is great for them. They don't even need the 9600. And but other people are wanting some faster, better data. We want to demonstrate that again, as I mentioned, with the LSC band uplinks. And we're also using that to pick off the signal from the L band uplink antenna to provide to the ADCS. We are looking at the possibility of having an X-band repeated, if you will, downlink of the VU for transponder use. So we'll pick off the signal from the transmitter on the UHF side and also feed it through X-band simultaneously. So Golf 1 was the actual stretch to reach greater orbit, larger footprint. 1,200 kilometers, roughly, was the target, and that was based on some of what I knew about launch possibilities and the fact that it's up there in the range of FL29807, so it could make a good supplement. And as I said, we're developing it from Golf T. So Golf T, you're going to find this flying stuff that may not necessarily be used. Our primary concern is those systems that I mentioned. But the aim for Golf 1 is to have the high-speed telemetry, 5 and dime transponders start using the microwaves, and I'm sorry if I faded out, and the option for the L and S links as well. Vanderbilt rate is going to fly an experiment, and there is going to be a Cameron experiment that Virginia Tech has offered to partner with a school yet to be determined as another educational aspect. Golf T was a technological CSLI. This one is, again, one of our staple education CSLIs. So, getting high in the Cubesat era. This was to do with the orbital debris compliance, and that's why the 1200 was crossed out on Golf 1, because we cannot achieve that. Short story on that is, NASA gave us the opportunity, and we came up with some good solutions, but none of them are approved by the FCC because they've never been done before the way we would do it on our Cubesat. And there's also the challenge that there aren't any devices specifically approved for Cubesats yet, so we're kind of stuck in a bit of a administrative catch there. So the regulation enforcement is very strict, and we knew that was coming. Of course, you want to take a shot, you don't just go, oh, well, okay, we give up. It has to re-enter within 25 years of launch currently. That's not what the regulation says, but that's the way they look at it, because CubeSats typically have had a relatively short lifetime, at least as far as reporting that their mission was active. In speaking and working with the FCC, we're looking at getting some leeway on that with our track record. The funny thing here is, we all know about how great AMSAT has done in the past. 807 is still up there after so many years, but when you take that as an example, these days, it's a new generation, it's a new mindset, it's new rules, and they don't view that so much as being something that you can say, our CubeSats will also do that as well. So we really have to pick up our reputation with that and build on it from the Fox ones and even Golf. But then, as I mentioned, we can't really get there anyway. We don't have the devices available yet, although I would expect that, knowing what we know from talking to various corporations. They know there's money to be made with Cubesats, so there will be things coming. The key is FCC holds the key to that because they issue the license. So the way the government works is they saddle them with the approval of that. You can't get a license, you can't get a launch. So I've been working closely with NASA and FCC to get how to get to those higher orbits, and with various companies that we have worked with throughout the Fox program, launch integrators and such like that, NASA and the people that they contract. The relationship that we have with NASA and now FCC is at least cordial, if not friendly. And that has taken some years to come about, but it is really paying off now. We're known as being by the book, and that's a quote, meaning that NASA is very pleased with the way we follow the rules and deliver our spacecraft in the way that they want to see. And in any case, the challenges are all part of the fun of doing amateur radio satellites. It sounds bleak, but then shoot, everybody that's spoken before me has been overcoming obstacles in the last 50 years. There are some other ways we're looking at, or we're actually active in, keeping amateur radios in space, and the Fox 1E transponder is one of them. It was, as it was being developed, the consideration came up that maybe we could package it and sell it, in a sense, so that other universities, whoever's building a Cubesat, could fly amateur radio for us. So that's been working out pretty nice, and we've been able to attract, Drew and I mostly work together on it, we've been able to attract and guide universities and FCC toward moving into Part 97 versus Part 5 experimental. This is a shot of the engineering model for HuskySat. And HuskySat, if you haven't heard of it, University of Washington project, they came to us years ago and said, we want to fly an amateur radio in our hands. And it's finally coming to fruition. They launch no earlier than November 2nd, I believe is the date, on Cygnus. So the deployment, I don't know. There's some discussion about whether Fox 1E or HuskySat will come first. What we did is we took the transponder and the Fox bus that we have so that we can keep manufacturing based on what we'll have and put a modified IHU on top that acts as an interface to a PC-104 connector and the whole satellite bus communicating in whatever fashion necessary in order for them to control us and turn us on and off, and even pass their telemetry. And also working with Frank and Eris, specifically Eric, so part of the team of International AMSAT and Eris, who are developing gateway radios. You want to know more about that? If you don't already, that's Frank. The Cubesat Developers Workshop this year was the first time that I was not alone in the sense of Joe was there about 2 years ago. Drew and I teamed up and had quite a good time there, actually. And we did present about the FCC Part 97, Part 5 licensing, and IARU process to help everybody through it. Because a lot of what happens is things get balled up, and people don't know how, or they submit the wrong information, or they go for the wrong kind of license. And I know from my contact with NASA that just causes a big mess. And often very close to integration. So I guess it was Fox 1B, there was a satellite on our launch, on our pod, that the night before integration got their approval, and they were in the position to not fly at all. They would have to be pulled, and there was another Cubesat standing by to take their spot. So as I mentioned, we also talked with Carl Kenzinger from FCC, he's International Bureau, and that was a nice long conversation, face-to-face, always beats email on the telephone, as well as Scott Higginbotham, who I know simply because he's been mission manager for a lot of launches, not spaceflight, of course. We also met with Dr. T.S. Kelso and discussed a bit about how do you find your Cubesat amongst those 104 that just got deployed. And that's all I have over the overview of what we do. So what I would like to do in about the next 20 minutes is, with the engineers that we have here, let them introduce themselves and give a brief description or somehow slides on the systems that we're working on for golf to achieve what we're going for. With that, first one up is Zach Metzinger, and I will just let him tell you more about who he is.
All right, Jerry tells me not to touch anything else, so I go once. Good afternoon. My name is Zach Metzinger, N0ZGO. I have spoken here the last couple of years. Some of you may have seen me, some of you may have not. I work with a wonderfully bright bunch of people. This is my first involvement in an AMSAT project. I'm really excited about it. And I am working on the hardware for the radiation tolerant IHU, which is the successor to the Foxtel IHU. It differs in that it has a dual independent processor architecture on the same card. So you can almost think of it as two LIHUs on one card. And it has EDAC. So what's come before us had EDAC. We've had long experience with processors that are systems that have had EDAC, but not processors that have EDAC built into them. EDAC is error detection and correction. You might have heard it as ECC, so ECC memories, things of that nature on other systems. So we have right now 3 working prototypes. So one is with Mr. Burns Fisher in, where are you? What's that? New Hampshire, that's right. I always forget that, sorry. And then there are 2 with me back in Dallas, Texas. One is remotely available for some of our developers to get into if they want to do some software development remotely. And then one I just keep on my desk for my personal use. The next version is almost ready for production, and we have fixed a glaring error in the first version of it. The bus switches were fixed. Some of you may wonder what this thing actually looks like in terms of a block diagram. I think there's a laser pointer right here. Okay. So the RTIHU has 2 CPUs on it. This is a TMS 570 CPU. They're both the same. Each side is the same. And there's some arbitration logic that watches these 2. These are automotive-grade processors, and they get their signals. They send their signals over to the arbiter. The arbiter looks at each of the signals and says, okay, is this one good or is this one good? And decides who to connect to the bus down here. This entire stack has everything all the way up to the SSPA, which is the solid-state power amplifier, digital radio chip called the AX5043, the main CPU, bus switch, power regulation on both sides. Then I've gone over that in previous year's symposiums, so we won't delve too deeply into that. If you're interested, take a look at the 2018 symposium proceedings. Who's got control? So the RTIHU is really two IHUs. One is in command, one is in standby. Independent power, CPU and radio. The bus switch is connected to the Golf bus, and then some arbitration logic that decides who has control of the bus. Last year I presented this picture, and I said, this is what it looks like with a rendered layout right over here. This is what it looked like in real life last year. Well, what does it look like this year? It looks like this, and this is a fully assembled card sitting on Burns's table somewhere in New Hampshire. And he and his team, they're doing the software, are doing all the software development for this board. That's really all I had, and I think we're going to probably hold questions till after everyone else is gone. So I'd like to bring Ray Roberge up, who's the next person to present, and he'll talk to you about SDR.
Okay, so I'm Ray Roberge, WA1CYB, and I've got an extremely simplified block diagram. So I looked at the regular block diagram, and it's got a lot of stuff in it. The SDR is only one of the items that Jerry talked about. Fundamentally, it's an SDR very similar to Mike's SDR that on Cubesat, which is a Rincon. It uses the same analog device chip, except the FPGA is different. For this, it's actually part of the EDIS E310, modified to go into space. We would have used the Rincon, but it's too big. This is only a 3U, he's got a 6U, I'm jealous. So we have a wideband antenna, it's a planar antenna. I'll show you a picture of that in a moment. And on the downlink, we have an X-band patch antenna, and I'll show you that picture. Signal comes in, it actually can come in at ULSC Actually, I tested it 2 meters also, it works pretty good. So comes in a wideband planar antenna. As Jerry said, one of the experiments is to use it at U. So I'll turn down the gain, and we'll actually receive the output of the transmitter from the IHU. It goes into an RF matrix board, which has low noise amplifiers. It also splits the signal out. I have a GPS on the ETA C310, and we have another GPS for the attitude control stuff. It comes in. I have 2 receive channels, like the Rencon board. It's really redundant. I'm really only using one at a time. The ETA is set up to have several modes. I've got 6, I'll call it fundamental modes that I'll show you, and I think it's in your proceedings. 3 downlink data streams and 3 operational ones. The output of the SDR goes into a mixer up converter, 10 gigahertz, feeds the X-band antenna. Okay, so what's the status? Antennas looking good. If you want to look at the planar antenna that covers the UHF to actually goes to 20 gigahertz. You can see the CQ magazine article that Ken put out, and recommend that. RF matrix board, we designed it, I tested it. Needs a little modification for C-band. It would make our noise figure a little too high, but it's in pretty good shape. Software-defined radio. I've got E310s. There are some design changes that we make to make it flight-worthy. And again, I'll describe what the modes are. I actually have probably 30 or 40 modes programmed. I'm not sure what we'll actually use in space, but they'll be there. So on Golf 1, you'll be more likely to use the other modes. So I have 3 bent pipe modes. So what that means is whatever comes in goes out. Keep in mind, the Doppler is pretty excessive at 600 kilometers in X-band, so the Doppler is around 400 kilohertz, plus or minus. So unfortunately, if you're not tracking it with an SDR, you're probably not going to be able to do it too well. Phil Karn says to me he can't, so I can't. But with that, a couple years ago, I demonstrated how to track this with a new radio, and it seemed to work pretty good. All will have a single tone to track, a CW ID, or other pulse stream, right? It's really a vector, so it can be SK31. I just use CW because it's easy. The first bent mode is I have 4 channels, about 25 kilohertz apart, 18 kilohertz bandwidth, and it has automatic AGC per channel and a squelch per channel. And it also has a 100 kilohertz bent pipe bandwidth, all separate. I'll show you a picture of these in a second. Example. The second bent pipe mode is 5 channels, 18 kilohertz apart, 100 kilohertz bent pipe bandwidth, and the third is 19 channels. So I get carried away. So I've been asked before, do I use RF knock in the FPGA? And yes, for some of the modes, specifically this one for sure. And this one uses RF knock. Other ones like this one does not use RF knock. So RF knock is a way to program the FPGA. And I certainly agree that FPGA programmers are hard to find out. So again, if you don't want to work with Mike, come and see me. It's hard. Okay, so here's an example of a bent pipe. I'm using Simon Brown's excellent SDR console software. And what I've done here is I kind of fudged it a little. I've adjusted the threshold in the flow graph to basically turn on with noise as opposed to detecting the signal. Because if I didn't have that, you wouldn't see anything in the output. Because it's really important to conserve power. So if nobody's using the channel, it's basically off on its own. So if nobody's using the wideband downlink, it won't be off. And if one guy's using the channel, all the power will be in here. So it's a way to prevent it from hogging bandwidth and that type of stuff. So here I've got 100 kilohertz bend pipe, and this one is the 5-channel bend pipe mode. But they all look kind of alike. And you can see here I have a CW constant tone that you can lock onto, and a CW downlink. Okay, downlink modes, this is the same. And what I've done here is I've got 3 different ways to bring down the data, GMSK, BPSK, OFDM, until I test out the final power amplifier. I don't know which one is really going to be the best. They look about the same right now. But here's one of them. This is the BPSK one. You know, you can see the little rabbit ears here, CW, and the ID. And right now that's set for 0.5 megahertz. The problem is I actually have a mode that does 50 megahertz bandwidth, but unless you've got a NASA space dish, you're not going to use it because the power spectral density is so low. But the SDR is perfectly capable of doing that. So we're set up for the future, and maybe we can get one of those ballooning antennas. That would be pretty good. Okay, so the only other thing I'd like to say is I've been asked what is the ground station. I actually use 2 Plutos because to test out a satellite you need 2 different ground stations to talk to it. So I use 2 different Plutos to talk up to the satellite and back down. Works pretty good. If you want to use it in a real system, you definitely need filters.
Go to the next slide.
Yep, antenna, X-band. And this is an earlier version. This is his normal commercial one. It only goes 700 megahertz to 26. But if you look at the CQ article, you'll see the modification. It's kind of like a hidden monopole in there to go to 400 megahertz.
Could I make one small correction? The red cardboard, just to defend them, and they're both P's and P's. The red cardboard can, its first 2 launches went on to 3U, not 6U. Oh.
I'm going to take it up. What I intend to do, and in the next maybe 7 minutes or so, because we have some of the engineering team here, and some of them may be here for the 100th anniversary, and we can reflect back on all this stuff. I'd like them to introduce themselves so that everybody has a kind of a feel, put a face on a component or something. Because of the short time, I had to suck it in a little bit, if you will. I think we'll just leave it at that, but if you could introduce yourself, something on what system you're working on, and why you decided to devote your life to doing this. That would be cool. And we'll start with Leandra. Come on up and say howdy.
Hi, I'm Leandra McLennan, AF1R, Alpha Fox 1 Radio, or a friend one remembers. I always use that when I have a lot of noise, and it usually comes through that way. So I'm an electrical engineer for my real job. So unfortunately, I've been promoted to principal engineer, which means I'm not doing engineering anymore. So I need another technical challenge, and I've been a ham for many, many years, always interested in VHF. Very active in VHF rovering in the New England area, and satellites are another VHF and another VHF challenge. So joining the AMSAT team. Right now I'm working on one of the boards is I'm a digital engineer. One of the boards is a catch-all with all the loose ends and all the power supplies and a one-shot. It's got the circuitry that will actually provide the current for the resistor burn. It's a catch-all to places that we don't have a home for anything else. So that's the board I'm working on in the golf.
And Rich, you're up.
Is K6GSJ here?
Hi, Rich Cobstein. I'm working on the software stuff with Burns. We will do in a second. So I was a ham starting in '82. In 1990, I got involved with satellites. Then life happened. Now I retired and decided that this is something I'd like to get involved with. I'm a software guy, so I'm working on the software for golf.
And Burns, nice segue. You're up next.
Only Bruce Hughes first. So I think the rest of us here are taking the KISS thing from yesterday to an extreme. We have many slides. So yeah, I'm Burns Fisher, Whiskey Bravo 1 Foxtrot Juliet. I have been interested in space stuff all my life. I remember John Glenn. I probably remember Sputnik. I'm not sure I remember that or not. I was alive anyway. And I have a letter from Deke Slayton saying, no, you can't be an astronaut, thank you very much. So I ended up being a software engineer for most of my career. Come time to retire, or I could see it in the near future, I said, well, I better join this AMSAT thing. Maybe I can actually volunteer to do stuff that NASA wouldn't pay me to do. I actually have to credit Phil Kern for introducing me to AMSAT many years ago on the Usenet, if anybody remembers that. So what I'm doing for AMSAT is writing software. That's what I do. I wrote a lot of the software. I was the project leader towards the end of the Fox software development, and now I'm writing software for the RTIHU and the legacy IHU on golf. And the really cool thing that's really interesting about doing the software for golf is that we've got both the RTIHU, which consists of 2 processors, and the legacy IHU, which is a Fox-like thing that has flight heritage. And we've got to get them talking to each other. And on my bench, they are actually talking to each other. And that was really cool and fun. Thanks.
And Chris Thompson, I think you remember him from yesterday.
Hello, I spoke yesterday, as you will. I spoke yesterday, as you heard. I'm Chris Thompson. I first got involved when I was an undergraduate at the university. I was at the University of Southampton, United Kingdom, and my final year project was actually creating a ground station for the university at that time, and working on the storing forward satellites that were orbiting from the University of Surrey. We did quite a bit of work with the University of Surrey at that time. And as Rich said, life kind of happened. I got a job and a wife and kids and all those different types of things. I was unfortunately less involved in the hobby, but I got involved again about 10 years ago. And I volunteered on Fox 1 to help put together the test conditions for Jerry. Like Burns, I was a software engineer most of my life. I did a lot of testing. I thought, yeah, I can put together a test problem. And we were lacking a tool to demodulate the telemetry and frankly just to prove out the test cases. So I just wrote a command line tool in Java at that time just to turn the audio coming out of an SDR. I think Jerry was using HD SDR, just to turn the audio back into the data so we could see that the tests were actually working. And that somehow became Fox Tele over a number of years, and we now use that for the Fox satellite. On golf, I think we're hoping it'll decode a legacy telemetry format, right? And all of the SDRs and so forth will be another new telemetry stream. But as part of golf, we'll have the legacy IHU and the RT IHU and the SDRs as experiments on golf team. And we'll still have the legacy telemetry stream. So
we'll decode that still from Fox to Lang. So thanks very much.
Eric, Josh, and Jay are not in here. So, Eric, Eric came to my recognition back in 2014, I think it was, when I put out the design of the next AMSAT satellite, and he submitted a very nice paper that is actually led to some of the design that's going into golf. So,
As Jerry said, my name is Eric Scoop, K1 Tango Victor Victor, and my first satellite contact was optical, about 1957. Some Russian bird, I don't remember the name. It squawked at about 20 megacycles per second. So. At any rate, I worked for 40 years as a system engineer in the Department of Defense and Intelligence Community on C4ISR systems, if you know that acronym. And I was been an AMSAT member for 30 plus years, but I never was really active until I found time retiring. As Jerry said, that time seemed to expand to 45 hours a week now. But at any rate, I joined the Fox program when it was about half through, Fox 1 Charlie and Delta. Did some testing on that, got really involved in Fox 1E and Husky Sat. And then we put those on the shelf. I transferred over to golf full-time, system engineer on that. We've been holding weekly engineering coordination meetings since early 2018. Next Wednesday will be our 69th weekly meeting. And that just gives you an idea of the coordination required among all the groups just to get this new golf design together. The only other thing I would add is we looked to the future, and Jerry came up with this great acronym for golf, but if we continue the phonetic progression and go to hotel, we were saying, I wonder what that would be. Highest orbit transfer for extreme lunar. Something like that. Anyway, the only point I would make is in the system engineering side, the perspective of a successful program here depends a lot on our Fox legacy. And that starts with people, the core Fox team, hopefully some members around for a lot longer. Jerry, Burns, Bob Davis, Chris, Dan, and as was mentioned earlier, our honorary Dr. J. and Dan Schultz, rather, and a few others I'm not mentioning, but their experience and lessons learned in Fox really transfer directly to golf. So we're using a lot of that thermal, structural, RF, electrical, mechanical, all of those disciplines are very important to our golf design. And beyond that, the golf space, the Fox space legacy of transferred units, and so I don't get claimed being too hardware biased or RF biased here. The software, you've heard Foxcom, we didn't mention too much about, that's our command uplink software by Dr. Carl Wick, and software down being punched in the back and then get off the stage. And those are important to us as well, but that experience is great for golf and we'll be used to that. That's it.
Thank you all on the team. I'm sorry we had to cut it short. Eric, please. A parting gift. So, really, not time for questions, but I certainly invite you to engage any of us, especially based on the system that you're interested in, and we'll be around for the rest of the evening at least. With that, I get to close with just one thought. You got to get to 4 houses before you get a hotel, so go on after. Thank you.
Jerry, don't run off. For leading this task, you get a full sleeve. So